Hello and welcome to our Learn Python series. Today we're going to see how effectively we can debug and handle errors in our application. So let's look at it. We have learned how to create a complete Python program. I'm pretty sure that you guys have done a great job of creating your own application, which is working as expected. It is giving you results as expected, but sometimes things happen. Applications stop working, they start showing errors, or they start producing results that were not expected. This is not a reflection on your programming skill. There could be things that are not in your control. For example, somebody may have deleted the data file, and the application is expecting a data file. It's not there. The Google Drive is not mounted, or that in your logic, you did not expect certain use case. Somebody is using your application or feeding it the data that you did not expect it to be given, and now it's producing some results that are completely unexpected. So there is nothing to panic about it. What you need to understand is that how do we quickly find what the problem is, where the problem is, then fix it and get back on track. So today I am gonna talk about two things. One is debugging, which is the art of finding the problem, meaning finding the cause of the problem. And then I'm gonna talk about error handling. That means that there are, in some cases, you are expecting some errors can handle, then how do I gracefully handle it so that the application does not completely stop working, but I still know what the error is. So let's look at what this error means. So I have intentionally introduced an error in our program that we wrote, and I run it. Now instead of getting my results, I'm seeing a long text. This is called traceback. You read it from the bottom. The last line tells you what the error is. For example, here it says no such file or directory. And then you start reading from the top. It tells you what events led to what. Events in programming means that what line of code called what line of code, and then what line of code was called by that, and eventually it leads to the problem. So here we can see that it started from our Analyze Student Performance module, line 36. So we go back in there and we see, okay, line 36, which is saying calling our module and passing it a file name. And you see, okay, that is the wrong file. So before we fix this, let me now show you error handling. Error handling means that I can expect this kind of error to happen, but I'm gonna handle it uh, depending on what that error could be. So this is called try except or exception handling. The way you can read this code, it says try, then the block of the code means try this block of the code, and if something unexpected happens, then do this. So we are saying if this error happens, meaning that there are certain errors that are well defined, for example, file not found error. Okay, for now we're just gonna say I am missing data file. That's all I'm gonna print. All right, so let's try to run our program now. And you can see it ran, but there was an error, and the error says I am missing data file. At least we very gracefully handled it. Now we're gonna fix it, and we're gonna change the file name and then run it. And now you can see that the application ran. I intentionally ran it on a Python command line because the intention of this lesson is not to show the charts, but to just talk about the concept of debugging. So now I'm keeping the output very simple. So that is one kind of error we have handled, and this is called a environmental error. Let's have another error here. I'm going to delete this line, and now we're going to run the program. Now you can see again an error which says name data reader is not defined, and then the traceback again starts from that line 36 led to then analyze performance module line 7. So let's open our module, and now since it is complaining, says line 7, see it's complaining on line 7 as the traceback said. And now you look at it and say, where is data reader definition? And we find that we forgot to import our data reader module here. All right, so at least we handle what was being told something's wrong on line 7. All right, now you can see we are back on track. So this is also an environmental problem that has happened and we fixed it. So let's look at another kind of error that can happen. Since it's a mathematical or numerical analysis that we are doing, one of the things that you do not do or is not allowed is dividing something by zero. For example, here, when you are computing the relative frequency, you are dividing the frequency by the total number of grades here. And for some reason, let's say that either something is wrong in the data or some computation ends up producing this to be zero. So then it will end up with a problem which will generate a NaN over not a number. So since we are expecting or we don't want this to happen, you can look at the code which says try computing the relative frequency, and if exception of zero division error happens, put the relative frequency to zero, but also print a message for the person who is running the application so that they are aware of it, that there was something wrong and a zero divide by zero occurred. So if the person then can go back and say why this happened, and then they can do some further analysis of this problem. So this is called a runtime error. All right. Then there is another kind of error that can happen. So let's look at the same line of code where we are computing our relative frequency. Let's say that when you were developing this program, at that point, you are working with very fixed set of data. Instead of computing the length of this array, you had hardwired because you knew there was only 40 data points, and then you run this. Now let me run this program, and you can see that there is no error. All right, let's look at visually now. Now you can see the problem here visually now. The pie chart, all the pie slices, they look kind of wrong. And especially the problem is the F grade here, that why there are so many students who have F grade. That is not expected. That means there must be something wrong in our computation. So let's go back to the same place where we have. That means to find a problem, these are called logical errors. To find logical problems, you need to understand the logic of your program. In this case, since the relative frequency is wrong, you go back to the place where you're computing relative frequency and try to find, is there something wrong there? And then you find that you have accidentally hardwired the frequency numbers here. The computation of the grades, length of the grades array, and now you put it back. This is the logical error. Means for the logical error, the application is not going to stop working, but you're going to end up with unexpected answers. So now we have seen there are three main categories of errors that happen: environmental errors, runtime errors, and logical errors. And then we have figured out that how we can look at the traceback to identify the source of the problem, and then we fix it and we put our application back on track. This is all we need to know about debugging and error handling. In the next chapter, we will talk about our best practices. Thanks for learning with us. Do subscribe and like our channel. For more information, do visit our website. Till next lesson, take care. Goodbye.